All right, we're going to talk about angle and angle measure today. And these are going to be some new types of angles that you haven't talked about before. Okay, geometry talked about angles maybe up to 360. We can go past that. What you need to know is what an angle, it means to be an angle in standard position. An angle is determined by two rays, which you should have learned back in geometry. The first ray for our angles in standard position will be called the initial side, and it will always be the positive x-axis. The degree measure of an angle in standard position is described by the amount and direction of rotation from the initial side, which lies along the positive x-axis, to the terminal side. So this is your initial side. I'm going to label it IS, and this would be your terminal side, TS. A counterclockwise rotation is associated with positive angle measure. If you go up from the x-axis and go around, that's going to be a positive angle. Your angle would be negative if you go down from the x-axis. Okay? So a counterclockwise rotation is associated with a positive angle, and a clockwise rotation is associated with a negative angle. Two or more angles in standard position with the same terminal side, meaning they land at the same place, are called coterminal angles. This is another term you're going to need to know. So we're going to, if you were to draw an angle with a measure of 210 in standard position, you would have to go from here, the initial side, all the way around to its terminal side. This angle is 210 because it's over 180. It would land it in quadrant 2. So it terminates in quadrant 2. And you need to know this is quadrant 1, 2, 3. Sorry, why did I say 2? Oh my gosh. 4. Oh, is that 3, 4, 5? What is it? It goes counterclockwise. 1, 2. This is quadrant 3. And this is quadrant 4. So it terminates in quadrant 3. I have no idea how I said 2 more than one time. That doesn't matter. We all know that was 3, right? So let's draw our own 210. So we go from here. Our initial side is going to be, again, the positive x-axis all the time. That's the initial side. We're going to terminate after. How come it takes us past here? Yeah, because this would be 90. This would be 180. Down here would be another 90. Yeah, 270, and then back to here would be 0 or 360. So if we're 210, we're just getting in this third quadrant. And that would be how you would draw it. Show me you know where it's beginning and ending. 305 degrees, we would be along the x-axis to start. That's our initial side. Our terminal side is going to go from 1 through 2, that 180, past the 270, and into quadrant 4. That's quadrant 4. That's 305, a representation of 305 degrees. Now 580 degrees. So we're going to have to show that our initial side, positive x-axis, we are going to actually have to spin all the way around once. Is once enough? Well, we're not done. We've only gone how much so far? Okay, so subtract 360 from the 580, and we'll get 220. So we have to keep going. Another 220, 180, and then some way into quadrant 3. That terminates in quadrant 3. Okay. Next one. Does anybody still need this? Okay. So you are showing that you know you went around once or more, or good luck. You're welcome. Bye-bye. Yay. All right, 135 degrees. We're going to hear about that one quite often. Again, our initial sides here, and you don't have to keep on labeling initial and terminal. Just know what it means. We would only end up in quadrant 2. Now we're going to go negative 450. I was going to save the red for my negative angles, so I'll go green. Just for fun. Negative 450, I have to go down and around. And now what? I'm going to add 360 to that so we know how much more to keep going would be a great idea. Negative 450 plus 360 is negative 90, right? So we keep going down till we hit, boom, right there. That would be the terminal side. It would be actually on a quadrant. A quadrantal angle is what we call the ones that aren't really in a quadrant. It's on the change between quadrants 2 and 3. All right, and negative 560. Let's go down and around and around. How much? Isn't that another negative 200? Okay, so we have to go another, let's see, down 180, a little past another 180, which would be actually in quadrant 2. Okay, terminal sides here. Sorry, I shouldn't have written that right underneath there. All right, now we're going to find an angle with a positive measure and an angle with a negative measure that are coterminal with 250 degrees. Once around, 360. So you add 360 and you subtract 360 from the angle you're given, and that'll give you one that's going to land in the same spot. So if I have a 65-degree angle, I'm going to find an angle with a positive and one that's negative. So sometimes you have to keep going till you get one of each. 65 plus 360 would be the easiest ones. I don't want you guys to go keep on adding, and give me these ginormous numbers that I have to check. Just give me the close ones, right? So 365 plus 360 would be 425 degrees. And then we'll do 65 minus 360 to get the negative one, and that's negative 295 degrees. 80 plus 360, I know you guys can just type that on your calculator and give them to me. Is that 440? All right, and 80 minus 360, negative 280. All right, 110, since 110 is within 360, 0 and 360, we'll just do the same process. Add 360 and subtract. All right, easy enough. Now I have to show you something. Why this is. Oh, what the heck? Yes, I am. Okay. Yes. Okay. Please, please. Yes, I did name it Heimer time now. All right. If this is a radius in a circle, now you have a baby circle down there on the right-hand side of your picture. I just wanted to be able to write this clearly instead of on the little one that's on that diagram. I'm going to just show you what a radian is. We're now going from degrees to radians. Radians? No. Yeah, leave it. Don't. There's rarely going to be a time you're going to put it in radians. So we're going to talk about if this is a radius of a circle, and this is another radius of the circle, and this length happens to equal the radius of the circle, that's what a radian is. So this would be equal to 1 radian. It's a measure of the angle. Yes. Yes, the length on this arc, this angle measure in radians is the length of the radius of the circle compared to the length of this arc compared to this radius of the circle. Now, I'll tell you what it is in degrees. That'll probably mean a little bit more. It's 57 point something degrees. Now I'll explain how you're going to get it before we go on. So let's think about this. If this is 0 degrees, but then I went all the way around, how many degrees would that be? Okay. 0 degrees at this location are 360. If I went straight up from there and across and drew a diameter, and I went through the vertical radius there down, these would be your quadrantals. So from here to here would be how many degrees? Okay. From here to here would be, okay. And then from here to here, 270. And then, okay, so we broke it up into quarters, right? Now, 360 degrees is the distance or the degree measure around a circle. We're going to talk about it now in radians. So I'm going to convert all these into radians. But first I'm going to tell you, let's let this circle have a radius of 1. You guys know from back in geometry, the circumference of a circle is 2 times pi times the radius, right? Or 2 times radius is the diameter. Diameter times pi is the circumference. This one's convenient to use because if I put in a 1 here, then the circumference of this circle is 2 pi units. 2 pi. It's 2 pi radians around. 2 pi radians. That means 360 is worth 2 pi radians. Now, put 360 in here for the circumference because you know angle measure, if that's equal to this, and then I divide by 2, I get 180 equals pi, divide by 2, 180 degrees is pi. Does that make sense here? This is pi. It's 2 pi around, then half a circle would be 1 pi. Now, what would half of that be right here? Okay, pi over 2. Now, half pi, 1 pi over 2, 2 pi over 2, 3 pi over 2. I will teach you the rest of the unit circle later, not now. I just wanted to check out the quadrantals. 90 degrees in radians is pi over 2. 180 degrees in radians is pi. 270, 3 pi over 2, 362 pi. Those are the measures in radians, and that's if the radius equals 1. Now, if I divide both of these by pi, both sides by pi here, I would get 180 degrees over pi equals, I divide by pi on both sides. What would this be then? Okay, this is leading us to the conversion factor. This is 1 radian. Check out what's on the box here. Now, what I just was doing, you could label on here 90 degrees, pi over 2, and this fits this one here. We're going to learn all the stuff in between that's on this circle eventually, and we'll be starting that later. Not today, and there actually will be a quiz before we even do this. So, pi over 2, this was 180 degrees, or pi radians. This one we said 270 degrees, or 3 pi over 2 in radians, and this here was 360 degrees or 2 pi radians. Those are the things I just labeled for you. So that's just the beginning. What I was trying to show you just now, 2 pi radians is 360 degrees, pi radians is worth 180 degrees. And then I went and took it to this point. 180 divided by pi will convert you from, which one is it? If we wanted to rewrite the radian measure of an angle into degrees, then you want to get rid of the radians, right? So you would put that on the bottom. 180 over pi would be on the top. You're going to go get degrees. So here's the conversion factors. This is super easy to remember if I just explain it from a problem. If I want to multiply this by something, meaning I want to go from degrees now to radians, what do I want to get rid of? Degrees. Okay, So degrees would need to go on the bottom. Dimensional analysis, remember? You guys have seen some dimensional analysis before. Thinking of it this way, degrees will cancel out, so pi radians will go on top. Okay, so we went from degrees to radians. That's this conversion factor. You don't have to write radians on it. So let's just do some cross multiplication or reducing. We're going to have 18 goes into 18 once, 18 goes into 180 10 times. So the answer to this is, thank you, pi over 10. Now it's in radians. And I'm not going to keep writing radians. If you want to convert 6 degrees to radians, you're going to multiply times pi over 180. Yep, to go from degrees to radians it is, because the degrees needs to cancel out. You'll have your 180 degrees on the bottom. This is your conversion factor. So if I were to reduce 6 pi over 180 degrees, that would reduce to pi over 30. See, the degrees are canceling out. So you can do this on your calculator also. You can type negative 72 divided by 180. And then you can hit your math enter button. If I can find it. Okay, negative 2/5. Now, what didn't I type in? Yeah, I didn't do the pi stuff. So that was negative, and now I just forgot what was on my calculator, but I probably can still. Negative 2/5. And you can do negative 2 pi over 5 if you want, or you can put the negative 2/5 right in front of pi. All right, calculate the next one. (41) pi over what? 9, 41/9 pi. And it's negative because the original angle was negative. Does anybody still need this page? Okay, then I'll move to the next one. Any questions about through 13? All right, 14. Now this one's in radians, so if it doesn't have a degree symbol, you know it's in radians. So I need to point something out. You can have 58 radians. It doesn't have to have pi on it, okay, to be a radian. You can, if the number is just plain old 5 and there's no degree on it for this unit, we need to know that means it's in radians, okay? So our angle measures should be labeled with degrees if they're degrees. These just happen to have the pi on them, and it's making them nice for our purposes right now. All right, so we're going to multiply this one instead. We want to turn it to degrees, so where would we want degrees? On top, right. Okay, 180 over pi. So that way now the pi will cancel out, but I do want you to understand that they didn't have to have pi on the answers, on the problem. So I got to do 4 times 180. 400 plus, it's going to be 720 degrees, right? All right. Multiply the next one again by 180 over pi. Because we have pi in both the radian measure and in our conversion factor, that's kind of convenient for those to cancel. 2 goes into 180 90 times. So we could do 5 times 90 and get 450 degrees. Okay, and I did want to add on to there that if this just a 5 means it's at 5 radians. 5 degrees is degrees. Okay. We're going to come across a problem today where we will have something that doesn't have the pi on it. Okay, so let's multiply again and then do the reducing. Conversion factor for always going to degrees will be 180 degrees divided by pi. That negative 810. Okay, and the last one, go ahead and convert. You can type, I just do manually cancel out those pi's and just type negative 7 times 180 divided by 12. And I believe that's negative 105. Okay. Anyone else still need this? We're good. All right, next one. Find an angle with a positive measure and an angle with a, uh-oh, these aren't in degrees. We want to find one with a positive and a negative measure that are coterminal with each angle. If they are in radians, if in radians, we need to add on how much? We're going to add and subtract, not 360. We want the equivalence of 360 in radians, which is 2 pi. All right, so if your answer starts in radians, it has to end in radians. Okay, now you could convert these back to degrees, add 360 and subtract 360, then you would have to convert them back to radians. Otherwise, it's going to get marked wrong. Come on, Matt. So we're going to take 2 pi over 5, and we're going to add 2 pi. We're also going to take 2 pi over 5 and subtract 2 pi. So I'm just going to write it like this, plus or minus 2 pi. The thing that we want to do is think about getting these into common denominators. So what would I need to do to get 2 pi to be in fifth? On the top and the bottom. Okay, so what I've actually got here is 2 pi over 5 plus or minus 10 pi over 5. Now I'm going to write my answers. 2 pi over 5 plus 10 pi over 5 would be 12 pi over 5. And the other answer, 2 pi over 5 minus 10 pi over 5 would be negative 8 pi over 5. Bless you. All right, next one. We are taking 5 pi over 6. And we're adding and subtracting 2 pi. We're going to get a common denominator by multiplying 2 pi by 6, top and bottom. That's going to give us 2 pi over 6 plus or minus 12 pi over 6. You want to get good at this because everything's in fraction form in this unit. 5 pi over 6 plus 12 pi over 6 would be 17 pi over 6 for one answer, and the negative answer will be, thank you, negative 7 pi over 6. All right, now, last one, negative 3 pi over 2 plus or minus 2 pi. I'm going to multiply this one by what? 2, top and bottom. Okay, I'm really showing all this work. I know some of you may have been able to write less than this, but I want it to be explained and shown clearly. Negative 3 pi over 2 plus positive 4 pi over 2 would be pi over 2. And negative 3 pi over 2, oops, I forgot to write the minus, negative 7 pi over 2. All right, next concept for today is on 13a. So we're going to do 13a, and that will be then the following page, 13B, has the beginning outline for your assignment, which is on page 820. Hey, just for fun, what was 180 degrees divided by pi? How many degrees is that? 57.2 and then a 9? Okay, round it for me to the nearest tenth since I hear multiple people at once. That's what I thought. Okay. That's 1 radian. That's how big a radian is. All right, let's move on from there. If we remember back in geometry, you did some arc measure formulas. You found the length of an arc. Arc length was degree measure divided by 360 times the circumference of the circle. This formula is for arc length. But this time, we're calling arc length S. Okay, and it's related to theta but theta must be in radians. So this is a new formula that's not in degrees, it's in radians. Last year when you did it in geometry, you did 360 out of, angle measure, central angle measure right here, out of 360 times the circumference. Well, we're going to find arc length now by doing the radius times the angle measure, and the angle measure must be in radians. If your angle is measured in radians, you're good to go with the formula. So S equals, in this case, the radius is 3.5 times theta. This would be theta. It is in radians. So we're just going to type this on the calculator now. 3.5 times pi divided by 2. Find your pi button. It is hit second and then the arrow up key. Should see pi on your calculator and then hit divided by 2. And that'll be 5.49 or 5.5. Now that's just going to be in plain units because it is length. Labels are critical in this unit to be accurate. S stands for arc length. Yep, S means arc length. So it does say up here, arc length for a circle with radius r and a central angle of theta in radians, the arc length S equals the product of r and theta, the radius and theta. So we just are popping numbers in now. 4.25 times 3 pi over 2. Okay. Just type it just like I said it. Not sure what you mean. Oh, okay. Oh, you meant arrow up instead of the arrow, the little caret key, if you will. Okay, I got it. 20.2 units. Oh, no, it was 20.0, wasn't it? Because that was 02. Was it 20.02? So if we're going to go to the 10th, it'd be 20.0. All right, please plug in this one. And when I did it earlier, I got 29.4 units. Are we okay? Second. All right, now we have an application problem. I don't know how many of you actually have clocks like the one on the wall in this classroom, but how many numbers are on there? We have to know that there are 12 hours in what part of a day? Half a day. Okay. There's 24 hours in a whole day. All right, now the 12, of course, is up here. Now, if you're going to go from 5 a.m. No, this is 6. I'm drawing a horrible looking clock. Let's just think about this. From 5 a.m. to 12 p.m., how many hours have passed? Okay, so that would be 1 plus, no, to 12, guys. From 5 a.m. to 12 p.m. would be 7. 1 plus 6. So it would be 7 hours plus from 12 p.m. to 10 p.m. would be 10 hours. Okay, so far what we've got here is 17 hours. We good? Now, if we want to know how many, it says, find both the degree and radian measures of the angle through which the hour hand on a clock rotates from 5 a.m. to 10 p.m. So far, all we figured out is that it rotated 17 hours. If there are 12 hours around the clock, and there's how many degrees going all the way around? Oh, you're getting, Max, explain where you got 30. Yes. Okay, there are 12 hours on the clock. Each hour it's rotating 30 degrees. Okay, so we need to convert by doing 17 hours times 30 degrees. For every hour, the hour hand will move 30 degrees. So that's going to be 510 degrees. And then we want to convert that to radians. So we'll do 510 times pi over 180 or 180 over pi. We want to get rid of degrees. So degrees goes on the bottom. Pi over 180. All right, and that will give us our answer in radians. And that should be 17 pi over 6 radians. Okay, the next problem has a truck with a 16-inch radius wheel, all its wheels, and it's driven 77 feet per second or 52.5 miles an hour. Find the measures of the angle through which the point on the outside of the wheel travels each second. Round to the nearest degree and nearest radian. Okay, so if we want to figure out what's going on, we know that there's an arc length is formula that said S equals R times theta. Well, what have we got that we could fill in? If it's going 77 feet per second, then it's traveling 77 feet in a second. So that would be our S. So 77 goes in for the length of around, how far it goes in a rotation around. The radius is 16 inches. Oh, no, wait, I'm going to write the labels on these. And then I got 16 inches here times theta. I want to know theta. So I'm going to have to divide by 16 inches, but we got a little bit of a problem. Right, we're going to have to change something so that their units are matching, right? Let's change the feet to inches. Okay, so let's do 77 feet. Change that to inches by, well, and that was feet per second. I'm going to leave that on there. Times, we want to get rid of feet, so we're going to put a foot on the bottom, and it's worth 12 inches on the top. So we are going to practice dimensional analysis to get our labels accurate. My pen stopped moving for a moment. Hold on a second. All right, my feet wipe out. I do 77 times 12, and I get 924 inches a second. All right, so far what I've got is 924 inches a second. That's equal to my 16 inches times theta. So what are we going to do now to get our angle? Yay, and the inches will go bye-bye. Okay, so 924, let's just divide that by 16, and that'll give us theta. Now that'll, by the way, this formula is going to give us theta in, wait a minute, in what? No. Theta is an angle. Radians. Okay, that'll be our radian answer. So 924 divided by 16 is 58, right? Point what? Yeah, you're getting 57.75, and it said to go to the nearest degree and nearest radian. So 58 radians. Remember how I told you radians don't have to have a pi on them? It's already converted into it, all right? It's already in there. So how are we going to change to degrees? We're still going to have to use the proper term, the proper conversion factor. We want degrees on top. So our conversion, 58, sorry, I don't know why I said 580. 58 times 180 over pi. And that's going to give us theta in degrees. Okay, so whatever you guys get when you do 58 times 180 divided by pi, I believe 3,323. Yeah, we're going to go the nearest degree, so shouldn't we just drop that? Okay. That's what you should be getting on the calculator. Do I need to type that in for anyone? No. Okay, your assignment, and we'll be doing this soon, playing around on our unit circle. We're going to learn how to fill this entire thing in. You eventually will know this well enough that you will be able to take a quiz with this blank circle and fill it in. Pardon? You'll get to practice, don't worry. It's not hard. I'm going to show you how to do it with patterns, and you'll know how to fill in everything on here. It's usually, most people get 100 to maybe 1 wrong. I'm not kidding. I will show you how to do it, but not today. There's a unit circle quiz eventually. All right, so your assignment, you can see an outline on the back of 13B worksheet is for the drawings, and then you're going to need a piece of paper to do the rest. And we have a little time left, so do you want to ask me any questions from yesterday? I can do that.